Hi, my name is ADIB.
Assalamualaikum and hi, I am FATIN NABILA.
Hi, I am ASMA ZULSYAZWINA.
Hi, I am NURAINA. Today we are going to present about our project, which is Water Reticulation Design Project.
The instructions of water reticulation. The basic principles in the design of a water reticulation system are reliability, utility, redundancy, and economy. Considering the volume of water required is another factor when planning and designing the system. The water moves with the help of energy and must overcome any resistance it encounters when changing elevation. The objective for these projects are: the first one is to determine the design flow, the second to analyze the residual head for the proposed pipe size, and lastly to propose a water supply reservoir and also pipe network. Before we proceed, the specifications of pipe that we use for this project. For pipe size, we decided to use size 200 mm for pipe diameter. Next, the material that we choose for this pipe is high density polyethylene, or also known as HDPE. We choose this material because it's easy to get quick installations, high resistance, and high flexibility. Lastly, the roughness coefficient for this pipe is 130. For water demand calculation, we calculate for 5-story hostel. We assume there are 240 persons for each block. Based on Malaysian Water Association (MWA) guidelines, as we can see, we get 345,600 liters per day. Next, for cafeteria, has been calculated based on the guideline provided by BOAS BINTI in January 2000. We get 2,055.5 liters per day. Finally, total of water demand for hotels and cafeteria, we get 382,421.05 liters per day times 2 loops, then we get 764,842.1 liters per day.
Hi, I will explain about how to get actual head loss and flow rate for each pipe. First, we need to draw loops and assume the flow rates for each pipes. And then, make a table like this for the first iteration. Roughness coefficient was given, which is 110, and since that, we can use the Hagen-Williams equation to find the H value and K value. Since the total head for 2 loops was not equals to 0, so we need to find the Q prime. The formula to find Q prime is shown as below. For joining pipes, the equation to find Q prime is different. When the total head loss for 2 loops was not equals or near to 0, we must repeat the same steps for the second iteration to make sure that the total head loss was equals or near to 0 in order to find the actual flow rates and head loss. That's all from me, thank you.
Next is residual head calculation. This calculation has 2 methods. For method 1, use the stated formula and tabulate the data below. From the calculation obtained, the value of the residual head is more than 7.6 meter, so the calculation is passed. Same goes to method 2. From the tabulated data shows that the values passed as there was no negative values.
To determine design flow, we need to find peak flow and fire flow. So, based on Malaysian Water Association guidelines, we identify that fire risk for parcel A is class B. Thus, the result shows that fire flow is larger than peak flow after include water demand in calculation. Therefore, for total water supply from reservoir, we use the Q design from the fire flow. The total water supply must include parcel M and parcel N because the reservoir also cater for both parcel. That may assume by 1.2Q and 0.8Q respectively. Thus give us the value of total water supply from reservoir are 13958.526.3 liters per day. Next, for the reservoir design, total daily demand that we get is 13958.53 meter cube. With this, we need to propose the design of water tank. So, we propose tank properties with 35 meter times 75 meter that give us 2,625 meters squared in area, which pass the land area available, which is 3,600 meters squared. We also propose the depth of tank with 6 meter. Thus, give us the volume provided of 50,750 50 meter cube, which is more and larger than volume of demand, which is 30,958 and 53 meter cube. That means it passed and okay.
Thank you. That's all from us.